All right, can you guys hear me? All right, well, thank you everyone for coming here on a Friday morning. It's great to see everyone's faces. So we're going to talk about Drosera Obscura project, where we are at with it and where we're going with it in the year 2025 and 2026. So before we get started, I'm going to show a couple projects before, just to get you acclimated what XR is. So this is called virtual sensory convergence, where we're trying to do 5 different senses in a VR environment. This started back when I was on research leave in 2019, 2020, and trying to incorporate those drawings that you saw into a VR experience where you're engaged with smell, touch, visuals, and also audio or sound. So really quickly, we're just showing you the processes that go through from drawing to modeling to rigging, and also for textures. For me, textures and colors, I always do a deep dive into biological textures for shoes, fashion. I really love fashion because a really beautiful array of colors that you can choose from. So this is my starting point before I go into a program called Substance Painter. And so I really wanted to push the elements of transparency within the game engine. And so we're utilizing Unreal Game Engine for this process. So you can see the processes that go through with rigging and all that. It's quite a long process. So for my research leave, I was down in New Zealand. And so I was invited to be part of Ars Electronica. And came back here and worked with ICAT to do a performance. David Renusich was a big help with this collaboration. Also, Tom Judson was kind of the chief engineer for the sound and kind of how this all worked within the ICAT cube space, utilizing the speakers within the system. So a shout out to Hiromi. Where is she? Raise your hand. Hiromi, she's shy, right in the back row, of course. She is an amazing puppeteer. She's shown twice in here. She's so awesome. But you can see these are forms that are tracked in real time. And so they're one-to-one. So as you go out to reach them, you're physically touching them. In the background, you see myself and my wife. We are also puppeteering a Wii remote for sound, real-time sound for the form. That goes to the bow speaker to the form. I'm also puppeteering, so when they're touching, I'm hitting buttons that's sitting off to the Unreal Engine. So in real time, you see this interactivity of this. So the participant also doesn't see the people, the puppeteers at the beginning. So there's about 20 puppeteers in the background, puppeteering about 8 forms. So the reason why I'm showing this is a second generation. So each year we try to tackle a different theme and more complexities to the XR environment. So again, using Vive trackers to track these forms in real time. You can see a puppeteered form. And this time we're trying to infuse scent into these cannons. So we have scent, fans, and a speaker in these cannons that you see. So as you get close to them in proximity, because we're using a game engine, we can trigger off sound and scent at the same time. So they are individualized with these cannons. So we have shown this at Seamus in New York City, also Ars Electronica and Linz, Austria. So just going to go rifle through a lot of this so we can get to our team and talk about our latest project. So Linz was awesome, probably 20,000 people got to kind of indirectly see it. And now we're up to our current research, all right? So we've learned a lot from our first 2 projects. And so we're very excited about these plastic static things, but we're wanting to shift to more animatronic forms. So how do you make animatronic forms happen within a VR space? So I know nothing about electronics. I think probably David and Dungsu will attest to that I should probably not touch electronics, but I had to kind of do a deep dive, learn, and so we're using Maya using scripts to talk to a Pololu, and in real time we can do animatronics, animations in a linear fashion. All right, so this is about 8 hours before the SIGGRAPH deadline for applications. So we finally got an animatronic working in a linear fashion, so it's playing from a script. It's not playing in real time with the Unreal game engine or anything like that. But with our proposal, we said that we were going to have this real-time interactions where you're touching those black spaces and having this real-time component to it, so it has this real direct feed into the game engine, also with haptic feedback and also sound. Again, pushing the limits on textures. I'm looking at Jason and Matt and Sydney. We're trying to really establish a really good sense of aesthetics with our characters. So anyways, you can just see kind of the breakdown of what that looks like in Substance Painter, pushing emissive lighting, also textures, and so forth. So this is 30 days before SIGGRAPH. We still haven't solved how to get the animatronics to come in real time with the game engine. So this is our pipeline. So we were using Max MSP jitter. You can see it sending a signal, and we finally cracked it and got it to go to Unreal. Also, that Max is also sending a signal to the game engine. Whoop, 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 whoop. All right. Sorry about that. That's real-time effects by Thomas, and also sound design by Thomas. So we got to do a presentation at SIGGRAPH. It was fantastic. I drove all these little bots all the way to Colorado. That was fun. And this is 5 days prior. Just solved it. You can see we're touching the black surface in real time. That is going to the Unreal game engine. So you can see the animatronics are in sync to the right hand of the screen, so you can see the Unreal game engine running in real time. So we had a lot of people. I think it was a 4-day event, probably about 18,000 people were at SIGGRAPH. So we got to talk to a lot of leaders in the field, from NVIDIA makers to people that do animations and robotics. So we got a lot of cool feedback from that experience. All days are trashed. Throughout the 4 days, things fatigued, things broke, a lot of tears from me, but we know, kind of know what we need to do going forward to make these stronger and more reliable. So we wanted to raise the bar, and so we were thinking we should do 5 interactive robots, non-tethered. So this is what we're going to talk about in the next 8 minutes. So we got ICAT seed grant to start in the fall. That's the core team that you see here, including Brooke. And then we also just received a McGill ICAT grant. And so we'll talk about that in just a second. But this is a team that we have established. So we have Ariana Wyatt included in this, and Brooke Kennedy also. We also have our external partners, Yaman, from the University of Bowling Green University. And we're going to go ahead and get started. We're going to talk about our current lab right now. And this is what it looks like right now. It's kind of a crazy place where we put any drawings that inspire us into the space. All right, so we're going to talk about Tom Judson. He's our sound designer, also our world builder. And Tom Judson was really good at looking at these drawings and creating a world to create this space. And so he realized they look a lot like this plant. And so this is where our title comes from the Drosera. So this is actual plant that lives, and so he brought up a narrative around that, and also Obscura. It goes back in time, but basically our VR goggles are an Obscura device, a camera Obscura device. So I thought that was really neat of this. So Jason is going to read a little bit of the backstory. All right.
Yeah, so Tom Judson provided us with a little explanation of what it's going to be. So Drosera Obscura, it's an immersive XR installation, set in a speculative post-human cranberry bog in the Pacific Northwest. It draws inspiration from Cranberry Farm Bog, and the piece imagines world shaped by climate collapse and ecological adaptation. It evolved carnivorous plants descending from the Drosera genus, have learned to survive in toxic environment, digesting insects with acid-producing mucus, communicating through subsonic sound, and converting microplastics into a protective shell. And you're about to see that in a couple of seconds here when Matt brings us out. But it was sort of like the plot around what we're trying to get to.
So before we didn't have kind of a backstory, and so people would ask us, what is this about? And so now that we're a bigger team, it's really helpful to have a story so we can make these connections and start building up layers of what the sound is going to be about, what the textures, what these bots are. So it's a good grounding point for us to have kind of a strong storyline. So Tom Judson just didn't write the script about the backstory, but he's also the person that's going to be helping with Unreal and Max, how to get these bots to talk to each other. So 5 of them, they'll be able to communicate with each other and also be able to communicate within the cube and also at McGill's large volume space. So we're using Max and Unreal as part of this process. Everything untethered, everything using Wi-Fi signals to talk to each other. So we do have Brooke Kennedy on our team, and he's been really great coming over and giving us gentle feedback on our project so far. So these are just kind of iterative sessions where he'll come in and talk about things that we need to work on to make the design better, make it more robust. Before, our things would fatigue. If we rolled it out, a leg would pop off or a finger would pop off. So having these conversations are really great for our team to get up some inspiration and so forth. All right. So we're going to move over to Sydney.
Hi, I'm Sydney Deco. I'm the industrial designer working on this project. I'm a sophomore in industrial design here. So yeah, this was one of the first things I worked on for the project. It was a scent cannon designed to like transfer scent, like those big scent cannons you saw earlier, but like smaller for the robot, so that when the user interacts with them, it will send a smell up to them. I'd spent a lot of time researching Disney's like smell-o-vision and like looking at their patents and stuff like that to sort of get an idea of what that should look like. And I also wanted to make the footprint really small because there's not a lot of space on the robot to house these things. And I ended up coming up with this design to house the motors and this design to house the scent. And the two of them together work to push that scent up, which was really cool to see. I also worked on creating a better aesthetic for the handle, sort of blending that natural feel of the robot, adding some felt and stuff like that, and as well as an ergonomic handle. And we also ended up adding buttons so that the puppeteer can make the robot do different things in real time, which is really cool. And I also added an ergonomic handle so it's easier for the puppeteer to move it around. So yeah. And additionally, we worked on different designs for the neck, like housing to make it safer, and we used flexible TPU plastic, but we didn't really like that design, so we're continuing to work on that and use fabric instead to better match that aesthetic of the robot, as well as still using TPU plastic to create that organic feel. Additionally, here are some nozzles that we've been working on the output of the scent. We want these to look really cool on the front of the robot to sort of break up that plastic. And so I designed a lot of different felt and plastic designs. Here's our first iteration. I hand cut it and we didn't really like it, so we ended up laser cutting it to make it look more clean. And here are some different iterations of that. The smallest one on the bottom is the one that you see on the robot today, which is pretty cool. And also we worked on housing for the robot. It was really important to like cover up all those parts at the back of it. And I wanted to make it snap-on with magnets, which is something that we're working on right now. And that will be my next big project to continue working on. So yeah, thank you for listening.
Hello, my name is Matt Finn. I am a junior in the Creative Technologies program here at Tech. The first thing that I worked on was a redesign of the base plate. That's going to be the bottom part right down here. So the first thing that we need for the base plate is some rotation at the top. The first base plate design was clamped to the bottom so it couldn't rotate between the top plate and the bottom plate. The second thing is it needs to be able to be taken apart. I can't show you that right now. It needs to be able to be maneuverable, like that. It has storage for power under it, and it needs to have a stable handle that can move it around. Right here is some ideation that I had. And then this is the final design without all of the hubbub on top. The one on the right is an STL file that I sent to Thomas for cutting out of wood, and then on the left is it all put together with a lazy Susan for rotation between the top and the bottom. So the improvements between this is it can now rotate on the top and the bottom. It has storage under for power. If you bend over and get on the floor, you can see that. And then also I added some wheel stabilizers because the earlier version of the base plate only had the wood, so the wheels would knock into the wood and make it looser, and then it would be harder to maneuver it. So I put these on. They kind of clamp on the top and the bottom so that there's less movability with the wheel and the base plate, and it won't damage it as much. So on the left there is it on Fusion 360. This is one of the last things I've been doing. It is a proximity touch sensor that will be up here on these little black parts. It will sense the capacitance change in a circuit. So when your hand gets near it, the electrical field of your hand will be sensed by the circuit, and it will brighten a light. The last thing here is I've been, in the future, I'll be working in Houdini, going into Unreal Engine, and working on particle systems for the VR project.
Hi everyone, my name is Jason Hodge. I am a sophomore in the Bachelor's of Fine Arts and Creative Technologies. And my kind of job was to kind of illuminate the max sort of solution that we're using at first. We want to really condense this down. So we kind of go through the pathway of Maya to Arduino, to Unreal Engine and C++. And here you can just see my Arduino software. The way we did this was taking our Arduino chip and reprogramming that so that it can integrate with Unreal seamlessly. One of the things we also had to worry about was the wireless kind of connection, and that's something we're going to be introducing so that all of our puppeteers will be able to do wirelessly and connect seamlessly like that. And so when we were thinking about doing Unreal Engine, how we were going to do this, all of our bones, so each animatronic and each puppeteer has its own bones that are correlated back to the code itself, and those positions are rapidly changing constantly in Unreal, and that's sending a seamless connection back into the animatronic itself, creating that seamless sort of motion that we have. So when it runs in Unreal, it's going to run in real life, and those same positions that you see in the software when you're in VR will also be what you see in real life. And this is sort of what it looks like ahead of time right now. On the left, this is what the servo motors look like. On the right is what the stepper motors look like. And this is what it looks like in Unreal and real life at the same time. And our sort of pathway is Maya to Arduino to Unreal to the robot itself. We eliminated Max as a feature because we wanted to see if we condense it down as much as possible. So right now, when you even run the VR system, you're also running the animatronic at the same time. And all those are done through the puppeteer's motions. You first saw the Maya animation that we had there. And each button that you press will play a different animation seamlessly and will show in real life and will show in Unreal itself. And this is some of the Arduino stuff, and this is what it looks like right now in this scene. This is sort of our demo scene, but we have that kind of cranberry bog feeling at night right now. We're sort of trying to figure out what that would look like, and it looks good. This is what, we're going back to Matt's particle effects in Houdini. This is some of the sort of models I've sketched up real quick. The goal of this is to be, you look up in the sky and you see some of these particle effects around you. And this is a tactile feedback suit that I'm also working on, so leading most of the code on this project. This allows us to use this vest as a haptic feedback vest, that when you do different things with the actual animatronic, you'll also feel them physically on your body, like rain or like different sound effects that are coming towards you. And yeah, thank you.
All right, Matthew Swartz is not here, but he's at Georgia Tech. He was going to come up, but he gave us his voice.
From driving touch inputs to servos, a speaker system potentially, which we eventually changed to another component. And then here's some early screenshots of some of those pieces, and some schematics and pinouts. We're using all the GPIO pins already, so we need a couple more for some of the button inputs. There are only 3 or 4 or 5 buttons, but this gives us up to 8 buttons, and there's a pinout for that. There are also some pumps that drive some of the sensing. And then there are 2 spots for Pololu breakout boards using the DRV8825, or it could use another one. Up here, we've also got this an encoder that feeds back in, so we have some feedback loop for the motor that goes at an angle. Here's all the MOSFETs for the 4 pumps. And then over up here in this part is the connector that goes out and up to the sub-control board. These boards are actually 4-layer boards, so we can provide more power on these. So the top layer, here's the second layer, which provides some power, and the one of the third layers, this looks like a ground layer, and then on the bottom, another ground, but also some other communications that go through on that. So all of those layer up, turn into this 3D model. We move over to the sub-control board. These haptic controllers, the DRV2605, have a lot of capabilities for different kinds of patterns. And one thing that we decided was to have multiple haptic motors, so we can even generate some spatial sense. In addition to the haptics, we also have some touch sensors. So the MPR 121 QR2s, there's 2 of these, and they have selectable I2C address. And then these are some LED and the LED and servo motor controllers. The board itself, down here is where the 24 volts and the signal comes in. The signal gets translated into a UART signal that goes into this feather as the main microcontroller. This daisy seed, and the daisy seed has an output that goes out to a line level. It has 3 different ways of audio signals coming out. We chose to use this out 1 and 2. 4 connectors for each of the haptic motors and each one of its chips that are separate, that are set up here. Here we've got the 2 chips for the touch chips, and all lined up at the top.
All right, I didn't tell you what that was. That is actually the board that's driving the whole animatronic. So from ground up, we're building that from scratch. So another lead is Dong-Soo.
Hi, I'm Dong-Soo Chea, School of Visual Art. So I usually trying to fix something or make it all together. So we created quite a bit of stuff. And on the video, you're seeing me installing the bracket. I designed that thing because we decided to go wireless, so we went to run on the battery, so that's I'm designing and put it together, and it survived to move to over here for the first time, so it worked. And then also I was soldering these boards that Matthew designed, and then I realized there's like about 300 soldering points. That means we have about 900 failure points when you put together, because you have to go through all those finger sensors and all that kind of stuff. So it becomes quite daunting very fast, and it could be really hazy-wise. So I have to make sure all that thing works, and even all these parts that were this thing breaks faster than the other. And how do you make the improvements, and how to make it all together? And then we also have to move all these units in Canada later. So all that kind of stuff, but the logistics portion of it is very important, and then has to be taken care of. So I'm in charge of all that part in a way, along with all the other people here. So thanks.
Cool. And I'm Thomas. I'm Thomas Tucker, and I don't do much. Basically, I hang out at 2 in the morning on a Saturday, and I just get to play around with the toys and hit buttons that don't work. But anyways, this is part of the process to kind of shake it down to see if anything's going to fatigue and break. But there's some really beautiful, wonderful moments that happen in the lab. I think I caught this right when Jason figured out the holy grail of how to get Unreal to talk to the Arduino and to the bot in real time. So that's one of those amazing times when you look around and look at your team and oh man, this is awesome to be here and at Virginia Tech. So we're almost done. I know we are getting the green light or red light over here. We do get a ICAT McGill grant, and so we will be performing at the ICAT Cube in the fall, hopefully October, and we'll be utilizing the Cube for this performance. We'll be workshopping it hopefully for a week. And then we will also, in the spring of 2026, we're going to go up to McGill and perform this, hopefully bring this whole team. So I'll be selling blood shortly so we can supply monies for our trip. So you can just see a little bit of what that looks like. Really quickly, I just want to give a little RIP to all the fallen heroes that have gone through the process. So these are all the iterative parts that we have gone through. We keep them all. Thank you to ICAT. Thank you, Ben. Thank you for all the support staff making our dreams come true. These are really amazing to be part of this. And if you want to watch a 15-minute video of Matthew Swartz talking about the board, there's a QR code. He gets into the nano detail. He loves talking about his board. So thank you, and thank you for your time this morning.
Thank you. Thank you so much for sharing your work. We have just a few minutes for questions. Do we have some questions in the room?
That's not a good sign.
There's definitely questions.
So animatronics is taking over a little bit of what the puppeteers were doing. How do you see the physical puppeteers manipulating these and integrating with the animatronics in the future?
Yeah, so what we have learned that there's a really great thing about having humans as part of the plastic forms. You know, as they go to reach out, you can tease and you can give a whole bunch of life with just the static forms. So we're still including that, but we're also including like these buttons. So once we know that it's a good time to maybe trigger off the scent, we'll be able to hit that button and it will send a signal and to Unreal and the particles will take place. So each of these buttons, and we can add more buttons. We have a whole arm here, but the buttons would be able to give some sort of interactivity. We also want to have this last one as a kill switch. So if things go sideways, which have happened in the lab, so we could kill just to kill it for safety. We're always thinking about safety. A lot of these coverings, also where the joints are, those are covered, so there's no pinching, so we're always concerned about safety. But training and workshopping to get these to come alive, and also about safety as part of the performance is a key factor. So yes, you are correct.
We are right at time.